morning, 8th grade. Today we are going to be learning module 8.6. And as you can see, module 8.6 is operations with rational expressions. And let's look at our learning target. I can add and subtract radical expressions, and I can multiply radical expressions. So that's what we are doing in today's lesson. Okay, so I am going to show you how similar adding and subtracting radical expressions is to monomials that we have already done. Okay, so I've written out some problems over here. To add or subtract radical expressions, the radicands must also be alike in the same way that in monomials that we have, this alike, the same variable or the same basis can be added in monomials or subtracted in monomials. The same holds true for radical expressions, but in this, the radicands must be alike. Okay? And what we're going to do, let me show you how to do this. I'm just showing you the similarity. When we had done monomials, we can see that the variable is the same. So what am I doing? The only thing I am going to do is I am going to group the coefficients because I have 5 A's and I have another 3 A's. So all I had to do in this case was 5 plus 3A. Okay, and I could just group it like this. And then I would add the coefficients, and 5 plus 3 gave me 8. So this is 8A. And that is how monomials was, right? And let's do a subtraction one too. Same thing here. I would separate the coefficients, which is 7 minus 2, and I have B, which is the same. The variable is the same. Okay, so then all I would do is I would subtract the coefficients because we have 7 B's. We reduce or take away 2 B's from there. So I'm left with 5B. And so this was my answer. Now look how similar radical expressions are to this. Okay, so as I said, the radicand has to be the same. And what is the radicand over here on the top one? It is root 3. So I'm going to treat it exactly how I treated the monomial. Okay, and because the radicand is the same, I am going to do the same thing, and I am going to do 5 plus 3. And I have root 3. And so, look, same thing. And now what is 5 plus 3? I get 8 root 3. And here's my answer. So once again, the radicand has got to be the same. Let's look at this one. Which radicand is the same? Root 5. So all I'm doing is I'm subtracting 7 minus 2, and I have root 5. And so I'm left with 5 root 5. So once again, please look between monomials and radical expressions. The principle is exactly the same. Just like we have to have the same variable over there, we have to have the same radicand over here. Okay? But again, the principle of adding and subtracting is exactly what we have done with monomials. So let's go ahead and solve some problems. All right, so here's a problem that I have put over here. And I have 4 root 5 plus 3 root 7 minus 2 root 5 plus 7 root 7. So let's look at which radicands are the same. So I have 4 root 5 minus 2 root 5. So this and this radicand are the same, right? And these two are the same. So we are going to group it together so I can add or subtract with the same radicand, okay? So I have 4 root 5, and I am going to move this there. Do not forget to take the sign. Just like when we had done with integers, you've got to take that sign along. And that's where you were making mistakes because you were adding or subtracting. So you've got to take the sign along, okay? So if this is minus, I'm going to take this over here. Minus 2 root 5 plus 3 root 7 plus 7 root 7. So look what I've done. I have grouped the similar radicands together. All right? And then next, all I have to do is I am removing this part. So let me do 4 minus 2 root 5 plus I have 3 plus 7 root 7. Okay, so look what I've done. Exactly what I was talking about earlier. And so what is 4 minus 2? I get 2 root 5 plus 3 plus 7 gives me 10 root 7. Okay, so now this is going to be my final answer. These radicands are different. Don't try to squish them together. Okay, so my final answer is 2 root 5 plus 10 root 7. Okay, let's do another problem. So here's another problem. And once again, I can see that the two radicands that are there are root 19 and root 6. So I'm going to group the root 19 ones together and the root 6 ones together. Okay, so I have 17 root 19, and then I have minus 3 root 19 minus 14 root 6 plus 11 root 6. And then all I do is I group them, and I have 17 minus 3 root 19. Okay, and then this is minus, so it's going to be the opposite sign. All right, so this is you are adding the opposite, right? So this is going to give me plus, I have negative 14 plus 11 root 6. Right? And so let's look at this. What is 17 minus 3? I get 14 root 19. And then because these are opposite signs, I'm going to add them. And so what am I left with? I have 14 minus 11. So what is the sign in the front? It's negative, right? So this is going to be minus, and I get 3 root 6. Okay, so here is my final answer. Okay. So here's another one. Do any of them have the same radicands? When I look at it like this, no. So I am going to do prime factorization again so that I can get a square root of some numbers to see if they have the same radicands. Okay, so I'm going to use the product property of square roots, and let me go ahead and do prime factorization with the first one. So if I have 75, I know that 25 times 3 gives me 75, right? So this is going to be 25 times 3. And what is 25? 25 is 5 times 5, right? So this is 5 times 5. So look, 5 squared, right? So I can rewrite this part as 3, and I can do square root of, so we are doing what? Times 5 squared. So once again, I am using the product property of square roots. Okay, so I have 3 times 5 squared times what's left? Root 3. Root 3. Right? And then let's see, if I do 48, I know that 12 times 4 gives me 48. And 3 times 4 gives me 12. So since I am talking about perfect squares, I'm not going to prime factorize anymore. I'm just looking at the two numbers because 4 squared is going to give me 16, right? So I am going to circle this and then I'm going to put it over here. So then next I have minus 6, right? And then this is times, then I have what? 4 squared, square root of 4 squared times here, root 3. And so next I'm looking at 27, and I know that 9 times 3 gives me 27. And then also 3 times 3. So look, there's my 3 squared. Okay, so in this case, I am going to do minus, and then it is saying square root of 27, and that becomes my, I have my square root of 3 squared times root 3. So now look, do we have common roots? Absolutely. But before we look at those common roots, let's go ahead and do the final process. Okay, and this one, I'm going to get, what is this going to become? This is going to become 5 because 5 squared, right? So this is 3 times 5 root 3, right? Because 5 times 5 is 25, and what is the square root of 25? I'd get 5. So I'm trying to remove everything from under the radical sign because I'm simplifying it, okay? Minus 6, and what is the square root of 4 squared? It's going to be 4, because what is the square root of 16? It is 4, right? So 4 times root 3 minus, what is the square root of 3 squared, or 9? I get 3. So minus 3 root 3. So then what we do is we are going to multiply the 3 times 5. Okay? And that is going to give me 15 root 3 minus 4 times 6 is 24. So 24 root 3 minus 3 root 3. Okay? Now, once I have that, I am going to just do what I had just learned. I am going to see, I can see that all the radicands are the same, so I can subtract, right? So I am going to put 15 minus 24 minus 3, and all of that, I have the same radicand, which is root 3. So when I do 15 minus 24 minus 3, I end up with negative 12 root 3. Negative 12 root 3. Okay? So once I have solved this and I have simplified, you can already see this is in the simplest form. So remember, when we have problems given to us with different radicands, remember the first rule of simplifying is that I've got to remove all the perfect squares from the radical symbol out. So that's what I am doing here. Look, 5 times 5, 25 is a perfect square. 4 times 4, which is 16, is a perfect square. 3 times 3, 9 is a perfect square, because then I'm going to get an integer value for that. Because square root of 25 is 5. Square root of 16 is going to be 4. Square root of 9 is going to be 3. And then I'm left with a common radicand, which is root 3. And so then I just solve how I just showed you. And then that's how I get to the simplest form. So here is a word problem for radical expressions. Decorations. Kate is decorating a rectangular pavilion for a party and wants to string lights along the edge of the roof. Two of the sides have a length of 13 root 5 feet and the other two sides have a length of 6 root 45 feet. How many feet of lights will Kate need to decorate the entire pavilion? So if I'm talking about the edge of the roof, I'm talking about perimeter. So if it's rectangular, we are going to have two lengths and we are going to have two widths. So that's how much lighting that Kate is going to need. So 13 root 5, and if this is one side, the other side is going to be the same, right? Plus, what do we have? We have 13 root 5. Because we're trying to see what's going all around the edge. And perimeter, once again, is two widths and two lengths. And then we have what is the other side. It is 6. So this is one. And then this is another one, which is 6 root 45. So plus 6 root 45 plus 6 root 45. Okay, so now what we are doing is we are going to obviously combine the same radicands together. Okay, and so I get 13 plus 13 root 5 plus I have 6 plus 6 root 45. And then what I'm doing, of course, I get over here 26 root 5 plus I get 12 root 45. Okay, now let's look at this part. Now I know that 45 can be simplified. Okay, if I do this, if I do prime factorization, I know that 9 times 5 is 45 and 3 times 3 is 9. So look, here's my perfect square, right? Here's my perfect square because I am trying to take out all the perfect squares out from under the radical symbol. And that is how we simplify. We cannot have a perfect square under the radical symbol. Okay? So once I do this, I have my 26 root 5 plus I have my 12 and I have, again now I'm using my properties and I have root 5 times root 3 squared. And what is 3 squared? Is 9. So what is the square root of 9 is 3. So I'm going to multiply the 12 with the 3. And so I end up with 26 root 5 plus 12 times this 3 over here is going to give me 36 root 5. Now look, I have the same, over here we have the same radicand. So now I can add or subtract. In this case, we are adding. So what is 26 plus 36? I get 62 root 5. And now this is my final answer. So I know that Kate will need 62 root 5 feet of lights to decorate the pavilion. And that's it. Okay? Now let's talk about multiplying radicands. So now let's look at multiplying radical expressions. Now once again, multiplying radical expressions is the same like when you were multiplying monomials that we learned. Okay, so I've written both so that you can see how similar they both are. And so let x be greater than equal to 0. And so if I have 5x times 3x, all that we did was we took the coefficients and we grouped it together and we did 5 times 3, right? And we took the variable, okay, and we did x times x. And so what is 5 times 3? It's going to give me 15, and x times x is x squared. Because the multiplication property over here, what does it tell me? That this is 1 and this is 1. And so we are just adding the exponents. So I get 15x squared when I am multiplying monomials, right? Now, let's look at this one here. Same thing. We are going to do 5 times 3, which is this part, and we can see the radicand is the same, okay, times root x times root x. And so that gives me 15, and 2 of these is going to give me x. All right, so root x times root x gives me x. So 15x is my answer. All right, now we can also multiply binomials. So let me show you how to do that. All right, so now I've written them next to each other so we can just see. This is binomials where we are having the same variable, which is x, and over here we are just having the same radicand, which is root 2. So I just want to show you using these values, okay? And both are absolutely the same. Now, we can use the distributive property, and that is basically we are multiplying each radical expression the same way, and we are multiplying with more than one term in each factor. So I'm going to show you the distributive property, but I'm also going to show you the FOIL method, which we have learned in competitions, okay? So for distributive property, I am going to multiply the 2x with the 4x and then 2x with the 5x. Then I'm going to take, because each factor has to be multiplied, then I'm going to do the 3x times the 4x plus 3x times 5x. Okay? So let's go ahead and do that. So first thing I do is 2x times 4x plus 2x times 5x plus. Okay? Then I am doing 3x times 4x plus 3x times 5x. So each term with each term in here. So we are using the distributive property. Okay? So now I have, what is 2x times 4x? It gives me 8x squared. Plus, I have 2x plus times 5x, and that is going to give me plus 10x squared plus 3x times 4x gives me 12x squared plus 3x times 15x gives me 15x squared. And then when I add them all, I get 45x squared. Okay, so this is going to be done exactly the same way like I did that. Okay, so 2 root 2 times 4 root 2 plus 2 root 2 times 5 root 2 plus 3 root 2 times 4 root 2 plus 3 root 2 times 5 root 2. So basically it's again distributive property. You are multiplying each term with each term in the other side. Okay, so let's go ahead and write it out. It's done the same way, and I have 2 root 2 times 4 root 2 plus 2 root 2 plus times 5 root 2 plus 3 root 2 times 4 root 2 plus 3 root 2 times 5 root 2. Okay, same thing. And so then I have what is 2 times 4? And that gives me 8. And then I have 2 of this, that means 2 squared. Right? Plus, I have 2 times 5, 10. And we have, again, same thing. Okay? Square root of 2 squared. Plus 3 times 4, and that gives me 12, and square root of 2 squared, plus 3 times 5 is 15, and square root of 2 squared. So that gives me, here, 8 plus 10 plus 12 plus 15. Okay, and then what do I have in here? 2 squared, right? And so when I'm adding everything up, I get 45. And what is 2 squared? 2 squared is 4. So what is the square root of 4? Is 2. So I do, okay, so because this is 4, square root of 4 is 2. I get 45 times 2, and I get my answer as 90. So look how simple that is. And please remember that when multiplying radical expressions, you multiply the radicands. Okay? I also wanted to quickly show you the FOIL method, which we have done. Okay? And so when we were multiplying binomials, so FOIL method of multiplying. Okay? So the F over here stands for first. First, outer, I stands for inner, L stands for last. Okay, so if I was doing the first ones, it is 2x times 4x. What does that give me? So I'm just going to write it over here. Okay, so this one. So we have 2x times 4x, which is here, 2x times 4x, and I get 8x squared. Okay, look. Then we have, let me just remove this so I can show you. All right, then we have outer. Outer is what? This and this. That's the outer, okay? So we have 2x times 5x, and that gives me 10x squared. Then we have inner. This is inner, these two, okay? So we have 3x times 4x, and I get 12x squared. And then I have the last, and the last is 3x and 5x, right? So that is going to be, last is 3x times 5x, and that gives me 15x squared. And now when I add all of these, look, same thing, 8, 10, 12, 15. It's the same thing. And so when I add all of these, I'm going to get 45x squared. So I just wanted to show you the FOIL method, which we are pretty familiar with in math competitions. It's the same thing. So the distributive property is nothing but the FOIL method. FOIL, first two that you are multiplying, the outer two, the inner two, and the last two. Okay, so look at how I've written it out. And this is a really easy way to be multiplying either radical expressions or binomials. Okay, it's the FOIL method. So here's a problem, and we are going to multiply radical expressions. So I am going to group this together for multiplying and group this. And remember, we can multiply the radicands. Okay, so I have 5 times 4, okay, and then I have root 3 times root 6. So what is 5 times 4? That gives me 20. And then I have my root 3 times root 6, which is going to give me, what is 3 times 6? Is 18. So I have 20 root 18. But I know that I cannot have any perfect square inside my radical symbol. So I have got to do prime factorization first. So if I look at 18, I know that 9 times 2 is 18 and 3 times 3 is going to be 9. So what is my perfect square? My perfect square is 9 because my square root of 9 is going to give me 3. So therefore, when I'm solving this, I will have to get this out of here. Because what does this mean? This means 20, right, times, then I have 3 squared, square root of that, times root 2, right? And so when I do the square root of 3 squared, which is 9, what is the square root of 9? I get 3. So therefore, I am going to get 20 times 3 root 2. And then I can do 20 times 3, which gives me 60. And so 60 root 2 is my answer. 60 root 2 is my answer. Okay? All right. Let's go ahead and do one last problem. So here's the last problem. We have done distributive property before when I have a number outside like this and I have 2 terms inside the parentheses by adding or subtracting. I have to multiply the term outside with each term inside. Okay, so distributive property, this times this plus this times this, and that is my distributive property. Distributive property. Okay, so let's go ahead and do the multiplication. So I know that this is going to be 4 root 7, right? 4 root 7 times 2 root 8, right? And then I'm going to have plus 4 root 7 times 3 root 7. So what is this going to be? This is going to be 4 times 2. So we are going to group it. 4 times 2, right? And then I'm going to group my radicands. So I can multiply those because I can multiply the radicands. Okay? Plus I have 4 times 3. And then I have root 7 times root 7. Okay, so what is 4 times 2? I get 8. And then I have, what is root 7 times root 8? And that is going to give me 56. All right, plus 4 times 3 gives me 12. And root 7 times root 7 gives me 49. Okay, now when I look at this, I know that the square root of 49 is going to be 7 because 7 squared is 49. Okay, so I can automatically put over there that this is going to be, because look, 7 times 7, right? So on this one, I can immediately do 12 times 7, right? Now, let's look at this side. So I'm going to do prime factorization, and I know that I have 2 times 28, and then I have 28 is again a composite, so 2 times 14. Now look, is 4 a perfect square? Yes, so it has to come out of the radical sign, okay? So this is going to be 8 times, we have 2, right? Because square root of 4 is 2. And then I have 14. So what is 8 times 2? That gives me 16 root 14. Because like root 49 gave me 7. So 12 times 7. And that gives me 16 root 14. 16 root 14 plus what is 12 times 7? That gives me 84. And there is my simplified version and my final answer to this problem. Okay, so once again, in module 8.6, please remember that you can add and subtract as well as multiply radical expressions using the same format that we did for monomials. Okay, and then for multiplying with binomials, I showed you how to do the distributive property, but also use the FOIL method, which you are familiar with in competitions. It's exactly the same thing because that is the distributive property. Okay, so first, outer, inner, last, and that's what you're using to multiply, just like you did binomials. The same thing you are going to have when you are doing rational expressions. And that concludes module 8.6. Have a great day, class.